This video is provided by Coaching Online IIT and delivered by Praveen Kumar Pandey. This is free tutorial videos which helps IIT and medical entrance exam aspirant in secure a rank. In all the lecture series we will solve previous year's question of IIT and medical entrance exam. We will solve physics, chemistry and mathematics question and explain all the fact related to problems in great depth, and an cutting edge analysis is provided. Our team upload one video per day. So to get daily update, subscribe our channel. Special thank you to my dad Shri Amrendra Kumar Pandey, G, and my mom Shri Mt Neelam Pandey, G. I dedicate this videos to my younger sister Miss Pratima Pandey. Thank you for tolerating me during making the videos. Without you this is not possible. Thank you.
Welcome to free online coaching. This is Praveen Kumar Pandey, your online tutor, and this is the class of Newton's law of motion. And in this class till now I had explained some, there is, if you look at common nature of problem, they are the body connected to each other directly. Okay, body connected to each other directly. And in this lecture I will give you some more detail of this such type of system. Okay guys, for example, some give you some illustrate some more example on it. Okay, for example, let's see here. Okay, here is a wedge. It is very simple question. Okay, this is a wedge. Don't be afraid with this one. Yeah, this is, and again this is. Okay guys, so this is a wedge. This is this okay, this mass is, let me give its mass. Its mass is 2m. Okay, and this mass is m. This mass is m. Okay, this mass is m, and here what is this angle? This angle is theta. Okay guys, hope you understand. This angle is theta. Okay, so there are two fundamental steps in solving Newton's law. First, which is exchangeable, whatever you want to do first think about how motion or acceleration motion occur. Okay, how motion occur and how they are related. Okay, related motion. For example, what is the relation between motion of block 2m and m? Okay, and how it occur, in which direction, how it occur, it means what is the direction of motion. Okay, and how it related means how, this means how m or 2m motion are related to each other by equation. Okay, and the second step is draw the free body diagram. Draw the free body diagram and draw the free body diagram and Newton's law. Okay, Newton's law. I should write it third step. Okay, and Newton's law is third step. Okay guys, so and all these three steps are very simple, and this is, if this is a nearly 50% step. If you able to do it, you had solved 50% question. You had able to do it, you had solved 40% question, and just 10% is this. Okay guys, and now, and what is the basic requirement skill to solve this, to do it? Just class 10th mathematics, up to class 10th mathematics. Okay, up to class 10th mathematics main, and slightly differentiation. What difference mean? That there is this guide, such thing of things, what should be it. Okay, so so this is the very simple, and this is again, and this is the very simple. Everybody, if you slightly work hard, then you find it. Okay, and this is again simple one. Okay, so Newton's law is simple question. Okay, don't afraid by seeing the lot of pulley, string, etc. These things are very simple. Okay guys, so you when you see this our lectures, you got confidence how to solve, how to encounter problem on Newton's law. Okay, this is m, this is m, this is 2m, this angle is theta. So okay, guys, I know I had one thing, that this can move either in this direction or in this direction. Okay guys, this guy can move either in this direction or in this direction. Okay, 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 this can move either, it cannot fly in air. Okay, it cannot fly in air. Okay, okay, it cannot fly in air. Okay, and this, you know this can only move downward. Okay, this can, because guys, this point is not going to leave, this can only move in vertical direction. Okay, this can only move in vertical direction. So okay, because it is not going to leave, this surface, and distance between this is not going to change, distance between this is not going to change. So what is the one restriction to move it in only vertical direction? Okay, when you do simple mathematics, you will realize this is going to move only, because this length is not going to change. Okay, this length is not going to change. So after some time, it this length is, let us check. This length is here. So after some time, this point will be reached here, and this point with respect to this will somewhere here. Okay guys, so so this, because this length is not going to change, so it will be something like this and something like this. Okay, so you had checked that this length, what I'm saying, that this length is not going to change, and this point will be something like this. Okay guys, okay, so this length is not going to change. It is only allowed to move, this m block is only allowed to move in vertical down direction. Okay, it is not allowed to move this and this, because here. Okay, so it is very simple to realize. Okay, now I had realized what is the sense of motion. Now I should try to find out there is any relation between the motions. There is any relation between the motion. There is any relation between the motion. If yes, then let's calculate. So uh, so let's check. Okay guys, let me draw this diagram once again. This is for you, so that there should be a clear view. Okay, this is m. Okay, this angle is theta, and this is m, this is 2m. Okay guys, so let's suppose this guy, this has moved by amount x, what I get here, yeah, this has moved by amount x, so I get this is, okay, this length is x. Okay guys, so since this length, it will reach here, somewhere here, and this will reach somewhere here, Okay guys, so if you see it clearly, then it becomes something like this. Okay, it becomes something like that. Okay, so what I had to do, I should, I have to find relationship. Okay, how motion of this is connected. Okay, I have to find relationship how motion of this is connected. Okay guys, so okay, so let's check. This is x, and this is the y, and this is x, Okay, so if you look at this carefully, this angle will be theta, this angle will be theta, Okay, this angle will be theta, and this angle will be theta. Okay, and this is y. So what can I write? Tan theta tan theta, this should be equal to y by x. Okay, so what is the y? Y is equal to x tan theta. Okay guys, so what can I write? Listen, I had find the relationship between what is the x and y. So if I differentiate it two times, so it become dy2 by dt2. This should be equal to upon dt2 tan theta. Okay, so this is the acceleration of, this is the ax, this is the acceleration of this guy. So what can I write? Ax tan theta. Okay, this is the ay. Okay, so it is very simple to calculate. What I am saying, this is the very simple to calculate. Now I had find out what should be the relation, what should be the direction of motion, and after that what should be the relation. Okay, now we are going to step 2. What is the step 2? To draw the free body diagram, and after that we will try to go to step 3. Okay, so draw the free body diagram. Okay guys, loads. So I'm going to draw free body diagram of this guy. Okay, this page. I'm going to draw free body diagram of this page. Okay guys, so it is just check, it is very simple for you to calculate. So it is very simple for you to calculate. So this angle is theta. Okay, this angle is theta, and here this is force by it is 2 mg. Force by it is 2 mg, and here there is a force. This force is by m kg block. This m kg block. Okay, this m kg block. So here is the normal reaction. Let me write its name n, and here is the normal reaction by ground, which is n2. Okay guys, so there is no motion in vertical direction. So let me, okay. So here is the only one motion is only x direction, this x. So guys, this only in this x direction, motion is only in x direction. So this x direction, so I should take this direction as my principal axis. I should take my x axis, principal axis, and perpendicular to it my y axis. Okay, so let me find the component of this force along this. Okay, so this angle is theta. This angle will be 90. This angle will be this angle will be 90 minus theta. This angle will be theta. Okay, this angle will be theta. It is very simple. This angle is theta, this angle will be 90 minus theta, this total is 90, this angle will be theta. Okay, so this is the n, what I get, n sin theta. In this direction there will be n sin theta. This is the n sin theta. This is n sin theta, and this should be equal to, this is n sin theta, this should be equal to 2ma. Okay guys, n sin theta. Okay. I had write the second law. Okay, I had draw the free body diagram, and then I try to solve it, and this. Okay, and again there is no force, there is no acceleration in perpendicular to it, so you have to balance it. And do it by yourself. Okay, do it by yourself, because if you are not able to balance this force, then you should work on yourself. Okay guys, only you can teach yourself. You should work hard to learn these things. Okay, and sin theta is equal to 2ma. Now what I have more, so I should draw the free body diagram for this guy. For m I should draw the free body diagram for this guy for m. So if you look it at very carefully, it will is something like this. Okay, here there, this is the normal force. Who has applied this normal force? Can you tell me who has applied this normal force? Yeah, you are right. This base has applied. Who has applied this normal force? This base. Okay guys, this wage has applied this normal force. This wage has applied this normal force. Who has applied this wage? This normal force applied by this wage. Okay guys, so let me check what happened. No, nothing else. So this is n. Okay, and here is the mg. Okay, and here is another force. who has applied this force? Let me call it N2. Okay, who has applied this force? This wall. Who has applied this force? This wall. Okay, this wall, the wall here, this wall. Okay guys, this wall has applied normal for this normal force. Okay, so this wall has applied. Okay guys, so you know this angle is theta, this angle is theta parallel. So and so this angle will be 90 minus theta, this angle will be theta, because this total angle is 90 degrees. This is the normal meaning of normal extension. This angle will be theta. So I should take component of this along this angle is theta, this angle will be theta. So what should I write? And cos theta, and actually this is coming downward. Okay, and this is coming down, so I should write mg minus n cos theta. This should be equal to MAY. Okay, listen here, I have two. If you think that this first step is not necessary, and you just draw the free body diagram and write the Newton's second law, which is the perception of a student. If you are able to draw the free body diagram and write the equation, then you are able to solve the equation. This is not going to happen, guys, because look how many variable here. This is, I don't know value of n, I do not know value of a, I do not know value of I. You had only two equation and three variable. You cannot solve it. Okay. To solve this equation, you need to think, to understand this step. What you need to understand this step. This how to find, how to analyze motion and acceleration, stabilize relationship between acceleration of bodies. Okay. So I had one extra equation. So if I replace ay is equal to ax tan theta, it will become very simple. So guys, mg minus n sin theta, this should be equal to mg minus n sin theta, this should be equal to m ax tan theta. Okay, let me write down it ax. Okay, mx. So if you okay, this is cos theta, no? This is cos theta. So if you look at this very carefully, I can write mg sin theta, okay, plus this should be equal to max tan theta sin theta. Okay guys, plus 2m ax cos theta, 2amx cos theta. Okay guys, 2mx cos theta, 2max cos theta. This will be equal to, okay, so you should do it how I had. This is your job to understand. Okay, you should do it by yourself. Okay, guys, by just seeing this lecture, you are not able to do anything. You should take your pen and copy in your hand and you solve the equation with me. Okay, so if you are not going to do it by yourself, you are not able to understand physics. Okay, so here look here, all these mg, this will be cancelled. I'm not going to write. So here g sin theta divided by, here this is nothing. Okay, this is nothing, so don't just deviate from your mind. And here we get what we get here, tan theta divided by sin theta plus 2 cos theta. This should be equal to ax. If you look, if I should slightly modify it, what it become, this become sin square theta g sin theta cos theta. I had modified it. Okay, if I had modified it, this becomes g sin theta cos theta divided by 1 plus, it becomes sin square theta plus 2 cos square theta, 1 plus cos square theta. Okay guys, this is equal to ax. So I had find what should be the acceleration. Okay guys, so hope guys this video you like it and share it among your friends. Thanks for watching. Okay guys, so in this series of lecture in which I start my basic lecture for Newton's law for class 11, just class 11 student, from this question, from this question, how to analyze this question from this question. After that, after explain the fact how normal reaction arise here, how normal reaction arise here, why there should be a force on, there should be a normal reaction, okay, if this is in equilibrium, etc. And till now I had solved this question, and and between them I had tried to establish three fundamental steps, three fundamental, and sometimes I call it two fundamental, whatever. The first is that it always, the first is this, how to establish a relationship between the accelerations, okay, how to establish acceleration relationship, how to analyze motion, okay. From first day I had tried to explain it, okay guys. So, and again to draw the free body diagram, and in all the free body diagram you had to encounter only two type of forces, normal reaction and mg, normal reaction and mg, okay. And it may possible that in some case this normal reaction is something like this on this inclined surfaces, my surface may be inclined, but yeah, it is in this case this, my normal reaction is something like this. So we had just two type of forces, this type normal reaction and mg, okay. And try to solve out, guys. In in our next lecture I will deliver you tomorrow. I will start that lecture from tomorrow, not from today. uh, I will explain some more forces like tension, okay. I will, and when tension, we will introduce some more forces to you, tension, and then spring, okay, then spring, tension and spring, okay. Tension, I will give some illustration, something to explain tension to you, what is the requirement to understand the tension forces, etc. And again after that, spring, okay. And initially we'll solve some easy question on tension, in which a body connected by connected by a string, okay, in which body is connected by a string, and try to solve the questions with the help of tension forces. Then after solving the simply connected tension forces, after that I will come to the fact that how simple and wedge connected, a string and wedge connected bodies play an important role and create a difficulties for you, okay, and make our life very difficult, okay. After that, first I will introduce tension, then after tension I will introduce you tension plus wedge, okay, tension plus wedge, and then I will introduce spring, okay. And after doing all these things, you are able to understand, you are able to encounter all type question of Newton's law, okay. And what is the basic requirement to solve Newton's law? That you are able to, you are just able to do this step or not, okay. And after that this, okay. And what is requirement to do class 10th mathematics? So just think, are you class 10 pass or not? If you are class 10 pass, then you had qualified to solve Newton's law, okay. So this required class 10 geometry, and slightly this and this guy, okay. And so it is very simple, this guy. What is the name of this guy? This is the acceleration, okay. Then understanding the free body diagram, okay. And free body diagram we will learn with every question. How to draw free body diagram we will learn with every question, okay. When I just delivering, I just started to deliver this lecture to you. I think that first thing I should explain you, I should teach you how to draw free body diagram. Then I think my student will don't know, because they are in class 10th, they come from class 10, they do not know what is the tension, okay. They do not know what is normal reaction, how it come in picture, okay. So also, so I should just escape to explain to to teach you how to draw freeboard diagram in first lecture. Okay, first lecture. What I think that I will teach you to draw freeboard diagram for in every lecture. Okay, in every lecture I introduce a little one forces one at a time, one forces one at a time. Okay, at a time. So till now I had explained you only one forces, which is normal action, and how it come in picture. If you want to know, then see my first lecture on, and here I had explained this. For this, there is a block of mass m which is kept on a table, and this cable is in a stationary state. Then how normal action come into the picture. Okay, so you should see that lecture. You should start seeing from this basics Newton law lecture from this point. Okay, because I had a the level of difficulties increases slightly step by step manner. Okay, now okay, so today I should just illustrate, give you some simple example on tensor, and from tomorrow class I will explain it to you. Okay guys, so let me check who has messaged me. Yes, company message, so don't bother. Okay, so okay, so let's come to the point. A simple question. This is a mass. This is support. Yeah, in physics we made support in this manner, and from this support, this is a string. This is a string. Okay, and this is mass of 1 kg. This is mass of 1 kg. Okay, guys, and this is in equilibrium. This is in stationary state. A stationary state. So look at the pattern. Look at the pattern here. To explain this thing again, I had assumed, I had give you that this is in a stationary state. Here again, to explain it, I had give you this is in a stationary state. So see the importance of a stationary state. Okay, so this is in a stationary state. Okay guys, so let me draw the freeboard diagram. Let me draw the freeboard. So stationary state means that this acceleration is 0. So I can escape this step easily, because I know what is the acceleration. I have not to find what should be the relation between the accelerations. Okay, how the acceleration is going to occur. I am not going to bother about it, because it is given in the question that this is in stationary state. So this first step is given in the question, Okay, now in second step I should draw the freeboard diagram. Okay, let me draw the freeboard diagram. There is only one force. This is the mg, which I know. But guys, if this is a force mg, this is 1g. Here take g is equal to 10 meter per second square. G is equal to 10 meter per second square. Okay, so this is the g. There is only one force. This is g Newton, and this is the g Newton. There is only one force here, and but if I say this is in equilibrium, how its acceleration would be 0? How its acceleration would be 0? To keep its acceleration 0, there must be a force. Okay, in upward direction and along the mg. Okay, along the mg and opposite to mg. Let me write it, call it clearly. Okay, along the mg and opposite. So this is my mg, along the mg. This line is my along the mg, and opposite. This means this is direction of mg, so opposite to it, just opposite. This will be my this is the force. Okay guys. Okay, guys, what is the name of this force? People call this force as a tension, because this force, who has applied this force? The string has applied. Okay, who has applied this force? String has applied. Okay guys, you hope you got feeling what is this is. Okay, so this is the f, this is the mg. So let me write down. If I, and this is tension, so I will from onward I will write it t. I will not write it f, because we the Newton's law people love writing tension. Okay, so I will we call it t, we represent it with t and call it tension. with love. Okay, so this is T. So what is the T? T is equal to mg. Okay, again guys, and this is by Newton's second law. By Newton's second law. Okay guys, second law. Okay, because why T is equal to mg? Because T minus mg, this is equal to 0 into, okay, this is 1, no, this is not m, this is 1. 0 into 1, this should be equal to 0. So what is the T is equal to mg? Oh, g, 1 into g. T is equal to 1 into g. Okay guys, okay, T is equal to 1 into g. Okay, okay, let me explain here. T is equal to 1 into g. T is equal to 1 into g. It is very simple to find, to calculate. Okay, now okay, so let's see. And question is, who had applied this T? Who has applied this force? Who has applied this force? Okay, string has applied, because string is connected with this mg. So who has applied this force? String has applied. String. Okay, this question is important, because this with this question we will feel the Newton third law. Who has applied this string? Who has applied this force? Who has applied this force? String has applied. On which string has applied this force? On block. Okay, this string has applied a force of d Newton on this block of mass 1 kg. This string has applied a force of d Newton on this block of mass 1 kg. So will this block will not apply, and this block will not apply the force on string. This block will not apply the force on string. Yeah, of course it will apply. So what should be the action? This is my string. Let me write down. This is my string. Let me make it slightly thick to understand it. This is the string. This is the string. Okay, guys, this is the string, and this is, and again, who has applied this force? String has applied. So this 1 kg block will also apply the force. Okay, 1 kg, this 1 kg block will also apply force on string. Okay, what is the amount? F. What is direction? Just opposite to it. What is the opposite to it? This will be the opposite. This will be this direction. Okay, so here this is the direction of force, F. This is the direction of force. Okay guys, so here this, okay, let me call it T. Okay, let me call it T. Okay, so guys, here there is no acceleration. To keep this acceleration 0, what should, then there must be a force which keep this acceleration 0. Here this force is this, and another second thing is this string is massless. Okay, this string is massless. So what is the here mass is equal to 0. Mass of this string is 0. So here, okay, this is retention. Here must be a force. Who has applied this force? This support. Who has applied this force? This support. Okay, and since this force is this force is by support on a string, so its name is tension T. This is again tension. Okay, and this both should be equal, because acceleration is 0. It has no mass. So T, this T, and here this F. Okay, this should be equal, because there is no acceleration. Okay guys, okay, so see you in next class. And if you like our, okay, I will explain you in more detail on this topic in my last lecture. And so if you are new on this channel, then subscribe our channel and like our video if you helpful for you. Okay guys, and okay, so thanks for watching this videos. Thank you.
Hey buddy, hope you understand whatever I am explaining to you. So work hard and enjoy the life. If you want to see me tomorrow, then subscribe my channel, because viewers like you support and motivate us to make videos. Please share this by clicking on the share button on Facebook, Twitter, Instagram, and other social networking sites so that a needy one get benefit and spread about it among your friends. My dear students, an important message for all of you. We are trying to take an online exam, which will be totally free for trial period means till July 2017. If you are interested in it, then you can register by sending an email or a message on WhatsApp. My WhatsApp number is 700-771-9110, or by giving this call on 7755896 We will give more detail about it in our forthcoming videos. Thank you so much.